Hello everyone, in this video we will explain how to connect Raspberry Pi RP2040 with W5100S module by writing Micropython scripts to achieve the effective TCP server communication. First, let's take a look at the table of contents of this chapter. It mainly divided into protocol introduction and introduction of WIZnet Ethernet chip with test demo. Chapter 1. Learn about TCP Server. TCP Server is a server-side program that uses an TCP protocol. TCP is a connection-oriented, reliable, byte stream-based transmission protocol used to transmit data over a computer network. TCP Server plays an important role in computer networks. It listens for client connection requests and establish a reliable connection with the client. For data transmission, in TCP Server, the server program needs to specify the listening port number and use TCP protocol to establish a connection with the client. Once a client connects, the server program will do this for each client to establish a separate connection and pass it through the data flow object to exchange data with clients. General TCP server creation steps. 1. Create a socket. 2. Bind the socket to the specified IP address and port number. 3. Start listening for connection requests from the client. 4. When a client requests a connection, accept the connection request and create a new socket, often called a subsocket, to handle communication with this client. 5. Exchange data with the client through subsockets. 6. Close the subsocket after completing the data exchange and continue to listen for connection requests from other clients. Advantages of TCP server mainly includes connection-oriented transmission, reliable data transfer, full duplex transmission, byte stream mode, emergency data transfer function. Application scenarios of TCP server include e-commerce platform, online game, instant messaging, remote monitoring, file transfer, online video conferencing. Chapter 2. WIZnet Ethernet chips. W5100S, W5500 and W6100 are the three mainstream Ethernet chips. From the table we found that 1. W5100S and W6100 support 8-bit data bus interface. Network transmission speed is better than W5500. 2. W6100 supports IPv6 and it is hardware compatible with W5100S. If users who already use W5100S need to support IPv6, they can easily upgrade to W6100. 3. W5500 has more sockets than W5100S, with larger send and receive buffers. Advantages of WIZnet Ethernet chip. WIZnet's Ethernet chip uses hardware protocol stack. Not only can it improve the efficiency of data transmission, it also reduces the workload of the MCU to allow low-end MCUs to be connected to Ethernet. Chapter 3. Simple demonstrations. Let's take a brief look at the flowchart first. First, initialize the SPI-related pins. Then set the network settings to dynamic IP acquisition mode. After that, determine whether the IP has successfully obtained. If obtained, print the obtained IP information. If dynamic IP cannot be obtained, use static IP. Then connect to the remote server. After the connection is successful, perform a data loopback test. In terms of software, we need Tiny Code Editor, WIZnet Your Tool Serial Port Debugging Tool, and Socket Tester Network Debugging Tool. For hardware, we need W5100S I/O module and Raspberry Pi Pico development board. Or we can directly use WIZnet's W5100S EVB Pico development board. In addition, we need to connect micro USB interface data cable and network cable to the RJ45 of the board. For UART and SPI settings, please refer to the table above. Next, take a look at the code part. We directly open the TCP_server.py file. Step 1. You can see it in the W500_init function. Initialized SPI and serial port, as well as registering SPI-related pins and reset pins into the library. The next step is to activate the network and use DHCP to configure network address information. When DHCP fails, then configure static network address information. When configuration is not successful, information about registers related to the network address will be printed out. It can help us better troubleshoot problems. Step 2. There is the operation of client monitoring. When a client connects, perform data sending and receiving tests. Then we run the program. After that, we open the UART debugging and socket tester network debugging tool. Set up client connection with the server. Then turn on the socket tester network debugging tool. Send message to the board. You can see a loopback message has been received. Messages sent by the client also appear on the serial port debugging tool. Indicates that the TCP server test is successful. This video ends here. Thank you everyone for watching. If you want to know more, please leave a message in the comment area or contact me via private message.